goes. It's Tanzu Tuesdays. Your host, Tiffany Jonatan.
Hello, welcome to Tanzu Tuesdays. As expected, it's on Tuesdays. If you haven't seen if you watched previously and haven't seen any of the recent episodes, you may have noticed that the time is at 12 Pacific time instead of at 1 Pacific time. So it will be staying that way going forward to help people in other countries be more likely to attend. So, okay. So a few days ago, actually, let's see, today is Tuesday. So last week we had our second Spring One tour of the year. So if you want to take a look at the video that we did for the first day, that'll be up in the next week or so. And if you are able to attend on a European time zone, we have a workshop, which is the same workshop that we just did, that will be coming up on, I believe, June 15th. And you can see this by going to Tanzu or spring1tour.io or tanzu.tv, and then you can go to Spring One Tour. So for next week for Tanzu Tuesdays, we have orchestrating data pipelines with data flow from Glenn Renfro. So that'll be May 25th. And again, that'll be at 12 p.m. Pacific time. So West Coast of the US, basically. So speaking of West Coast of the US, hi, Jonatan, or Joni, welcome.
Hi. Thank you for having me.
And I think so I've had one other person on here who is from nearby, but we're actually the same city.
Yeah. Well, actually, I live
no.
next to Seattle in Bellevue.
Okay. All right. So we're not in the same city.
It's essentially the same area.
The Seattle metro area. Yeah.
Yeah.
I was in Bellevue for the first time in a long while, just last week. So I was like, oh, hey, this is what Bellevue looks the same.
Yeah. Well, there are a lot of construction sites nowadays. That's a little bit different, but other than that, yeah, it looks
True.
pretty similar.
More companies moving in. Yeah, and then your background where it's actually nice and sunny, I think it kind of actually matches today.
Yeah.
Because yes, it does not always rain here.
Yeah, and as far as I know,
have you been over here?
I moved here in 2016, in the beginning of the year. Previously, I lived in Hungary. I am from Hungary. I'm Hungarian. That's why I have this weird name.
For a conference. It's cool. I just have American pronunciation issues.
No, that's totally fine. Usually I go with
at a
Jonatan.
Conference there. Yeah, but I can't do that because there's no H. I look at your name, there's no H, so I just can't. But yeah, so let's see. Have any favorite hobbies or anything like that you've been doing?
I used to do fishing when I when I lived back in Hungary, and my hobbies nowadays are I like running and cycling, and also I do electronics, which is building small little things from parts. I'm not 100% sure I will be able to show it, but for example, this one I built this is kind of it's like an extra keyboard. I use it to control the music and the volume with that. So with the knob, I can increase or decrease the volume, stop the music, jump to the next track, and so on.
Yeah, for me instead, it's oh, it's a little loud. Here, let me click this thing in my bar and then scroll the volume down. That's definitely nicer. Also, I need someone to rub off the I like running onto me because I hate running, but I need to. So it's kind of this dilemma. So if you could be like, when you're able to go and travel again, do you know where you would want to go first?
That's a great question. I have no idea. I believe this year, maybe like towards the fall or the end of the year, I should go back to Hungary to visit friends and family. Other than that, I haven't thought about it because I have no idea when will the restrictions be lifted.
That's true. That's true. For me, I'm just right now being like, so where in the US can I go? Like, but even then, I'm still scared. Like, I'm fully vaccinated. I have like an N95. I'm still like, what about restaurants there and all those things? So for now, I have not gone anywhere. But yeah, so want to tell us a little bit about yourself that you're not already going to be doing in the presentation, and then I'll let you kick it off.
Okay. So my name is Jonathan, and I work in the Spring engineering team, mostly in the observability area. And this practically means that I work on Micrometer and Spring Cloud Sloop. And I am kind of a new addition to the Spring team. I started in December. And since there is not too much information about the Spring team, what's life in it or what's the interviewing process like, I thought that this is a good opportunity to talk a little bit about it, about my interviewing experience and how's life in the Spring team. And this is also a good opportunity to ask questions. So all of you who is watching this stream, please feel free to send questions in the comments.
For people who might not know, what's a quick synopsis of what Micrometer and Spring Cloud Sloop are?
Mm-hmm. So Micrometer is basically a metrics library. It's not a strictly Spring project. It can be used without Spring. It is basically a metrics facade, like SLF4J, but for metrics. But I will talk about this in the presentation. And Spring Cloud Sloop is for distributed tracing. It's a Spring-based project. It is part of the Spring portfolio, and it is basically giving you distributed tracing support for Spring.
Awesome. Cool. Well, I'll let you take it off now.
Okay, so people already sent me a couple of questions that kind of nicely aligns with this topic. So let me start with those, and in the meantime, let's check the comments. So the first question was what was the interviewing process like? And a small disclaimer here that it was only my experience. So your mileage may vary a lot depending on the team or who is interviewing you. And I was only one candidate, so I have only one data point. I haven't been on the other side of the interviews. So there are a lot of things I don't know about the process. But what happened to me is I applied at the end of May in 2020. And I saw the job posting on Twitter, posted by multiple Spring engineers that I follow. So if you want to be aware of this job posting, then follow us on Twitter. And if there are new openings, you will see them circulating there. And also you can find those on the VMware job site. For example, as far as I know, we have an opening for a dev advocate position right now. The interviewing process for me, it was a pretty long one. I applied at the end of May, as far as I remember, and I accepted the offer at the end of October. That was like 5 months to go through the whole process. And there were three interviews during this with 5 interviewers, and I also got 2 homework assignments. And the interviews were pretty interesting to me, sort of like non-conventional here in the US, but that's like a great thing. I really enjoyed them. So they were trying to have a diverse panel of interviewers. and also a diverse panel of a diverse pool of candidates. And as far as I know, the interviewing process doesn't start here in the Spring team until there is at least one qualified candidate from a underrepresented group in the pool of applicants. And this was quite positive when I heard about that, and this was one of the factors why the interviewing process was so long. During the interviews, I got mostly like technical questions about my background, my experience, my opinion, mostly about like observability topics, because that was my like domain area or area of expertise. Also like questions about tracing, metrics, Spring itself, also distributed systems. And a lot of these topics, or some of them at least, were pretty overlapping. And this was in order to avoid bias from the interviewers. And also, every technical interview, they were always done by 2 interviewers. This is also for avoiding bias. And what I was referring to in the beginning, when I said that it was like a pretty unconventional loop of interview, it is because there were no coding or design exercises during these, which is, I believe it's still in Europe, it's pretty common, but in the US really likes to have this lead code like coding exercises during interviews. Though, on the other hand, I have a bunch of code on GitHub. So if anyone is curious about what kind of code I write, it's easy to check. So these were basically the interviews. I believe the last interview was finished in, I don't know, August or something. So it was quite some time. And I also got like 2 homework assignments. Those were like 2 problems in the observability problem space. And the task was basically creating a sort of like analysis of those problems. This means that it was basically a write-up about what I think about the problem space and how I would tackle those problems, but writing actual code wasn't mandatory. It was allowed. You can write code on these exercises if you want, but if you don't want to, that is totally fine too. So that was basically it. 5 months. It was, I would say, it was pretty hard, and I did not even know that I will be invited for the interview after I applied. But other than that, like yeah, I started in December, so I'm pretty happy about that. Okay, if we don't have comments or questions in the chat, I can continue with another one that somebody sent to me earlier on Twitter, I guess. So the question is, what are the best and the worst things like working in this Spring team? And I believe this is a pretty hard question. And I would start with the maybe the simpler one, or I'm not sure if it's a simpler one, but let me start with the worst. Then maybe because this is simpler to me because I'm Hungarian, we can complain a lot about anything. It's pretty easy for us. So I believe the worst thing working or being in the Spring team is like losing direct exposure to production. Though I don't necessarily mind this because there are aspects of this that are not necessarily bad. But there are also possibilities to work with customers, so you can gain back these elsewhere. And the best thing is like when I get this question, I basically just say like, come on, like it's the Spring team. It's like open source work. There are a lot of users, and the Spring team is really awesome. I believe this is one of the best jobs on the world I can imagine, though don't mention this to my manager.
Also, you get stuck with having to deal with people like me.
Yeah, exactly. Yeah, so the team is pretty awesome. I really like to work with the people the Spring team. Okay. Okay, let me jump to the next question. What are the next upcoming features in Spring? So I can mention a few, but I can teach you how to fish as well, so that you can get notified about this. You can follow the Spring team, so the Spring engineering blog. I guess it's spring.io/blog. Let me put this into the comments. That you can follow, and new announcements will be there. Also, Josh Long, he has a This Week in Spring series, I guess that's the title, where he basically recaps every week what happened in the Spring world in the previous week. You can follow Spring engineers on Twitter. They will also tweet about things and new releases. And there are other things which are less known. For example, we have a release calendar. It's calendar.spring.io, and it's basically like a Google Calendar, and you can go there and you can see what are the upcoming releases. And it's public, it's open. You will be able to see it. Also, there are more hidden gems that you can look into. For example, we have incubator GitHub organizations, so that you can go there and see what is baking, and you can see all of those projects that are already public but haven't been released. And you can also check the Spring repos. We have our own repositories. Repo.spring.io, as far as I know, and /snapshot and /milestone. You can see the latest versions published there. But I believe going to the repos on GitHub is an easier way to see what is going on. And there are two bigger features that I can mention right now that they are in progress, and hopefully will be released soon. One is Spring Native, which is the native image support for the whole Spring portfolio. And the other one is, I am involved in it, it's Spring Cloud Sleuth Hotel, which is the OpenTelemetry support for Spring Cloud Sleuth. I will talk about this later in my presentation. Okay, has anyone sent any questions on Twitch?
I don't know if this was specifically to you, but Sweet Killer 9 was asking how are you dealing with time zones?
Oh yeah, that's a great one. So, and that's a hard one. Before I joined the Spring team, when I was working in Hungary to another company, I was working with US West Coast. That's like a 9 hours of time difference. Then when I moved to the US 5 years ago, I was working from the US with Hungary. And I did this for almost 10 years. So this 9 hours time difference, it was always there in my life. And it's a little bit harder nowadays, because it wasn't just this, it is not just the 9 hours time difference I need to deal with. It is way more, because I am working with Tommy Ludwig, who is the lead of the Micrometer project, and he's in Tokyo. So I have with like 8 hours time difference, and I am working with Marcin, who is in Poland and who is the leader of Spring Cloud Sleuth. So we have like -9 hours time difference. So the three of us basically pretty much covered the globe. So it's not easy. If we want to have a face-to-face meeting, that means one of us will need to be there in very early or very late. So mostly what we are doing is doing most of the things asynchronously. like over Slack or over Google Docs. And also we have fixed meetings, the two of us, because like two people like can deal with that 8-hour time difference. That's not bad at all. So we are basically like doing this rotation, and the two of us are meeting every week in like every combination.
What Spring products are the most exciting for you?
I am going to like the most exciting right now. I believe it is Spring Native, because that is a big step for Spring. I think this native image, it will be a big feature once it is like released for GA. It will be a very big thing. Right now you can try it out. As far as I know, like 0.10 just came out, and it covers a lot of things. So if you want to try out what it is look like to run Spring like natively with a native image feature in like using GraalVM, then you can do it with Spring Native.
Yeah, Josh was showing me some stuff with Spring Native recently. We were going to try to have it as part of Spring One Tour, but we were limited on time. But yeah, just it's like his second favorite place on the internet. Start at spring.io and then add in the Spring Native dependency.
Yeah. Okay. Speaking of which, let's move to the presentation if we don't have other questions. And for that, let me share my screen. Okay, can you see it? It should say observability beyond logging metrics tracing with Spring. Can you hear me?
Yes, can you hear me?
Okay. Oh yeah. Now it's okay. So I am going to talk about observability and what is beyond logging metrics tracing, and what Spring can provide you in this area. So this is our agenda. I am going to talk about what is observability, why do we need it, what are the 3 pillars that are usually like mentioned around observability, what can Spring offer for you in terms of logging metrics and distributed tracing. And I can also talk a little bit about some non-conventional observability components, which might be, for me at least, the most interesting part of this presentation. Okay, so this is the definition from Wikipedia. So in control theory, observability is a measure of how well the internal state of the system can be inferred from knowledge of its external outputs. And also a system is said to be observable if the current state of the estimate is using only the information from outputs. So now you know what observability is. It's obvious for everyone. We can continue, right? And it's not that fast. Observability is basically how well we can understand the internals of a system based on its outputs. And basically the question is that is this, or is an output give you meaningful information about what is going on inside of your system? And if so, then yeah, it probably makes your system more observable. And meaningful is a key term here. Just adding more data won't necessarily mean a more observable system. So also observability is a key from the perspective of controllability. And I believe, Tiffany, it was you who talked about this last week with Kubernetes controllers. So in order to control something, you need to be able to observe it. It's basically like a coming pair. It's very hard to control something that you cannot observe. For example, if you have a thermometer in your room, and if you want to set the temperature to something, then basically you have a current state and a desired state, and your thermostat can act based on the current and the desired state. But what if you don't have a thermometer in the room? Or what if the thermometer is outside of the room? And I'm not joking with this one. An outside thermometer is actually a thing. So if you want to control something, you need to be able to observe it. And if you search for like open or closed control loops, then you will find out that this has a huge branch of science that is about automation or just like control loops, and also about observability. So it's not just for software, but what we are interested about right now mostly is what does observability mean for software? So our software ecosystems are usually more complicated than reading a thermometer. And this is why we want to ask arbitrary questions about our systems, especially like those questions we don't necessarily know prior asking them. And also we would like to turn data points and contexts into insights so that we can troubleshoot problems quickly without prior knowledge of the system, especially unknown unknowns. And also, observability should, by definition, increase operational visibility and developer productivity if we are talking about software. And all of these things, this leads us to the next slide, which are like 3 spheres or something. Does anyone know what are these images?
I feel like it's a cheat because it kind of tells you.
Well, it almost. So these are called like Deathstar architectures, or it is also called like a big ball of mud. But these are like from left to right: Amazon, Netflix, and Twitter. And as far as I know, like this is I might be lying because these images are like circulating on the internet. So the first image, Amazon, is from 2008. That wasn't yesterday. Netflix, I don't have the information where is that image from, and Twitter should be from 2013. So these images are much, much, much worse today. And that's why we cannot really predict what is going to happen. We need to face like unknown unknowns. We are in the cloud, so the size and the complexity of our systems are huge, are enormous. We don't really have the LAMP stack anymore. Like when you have just a web server with PHP and MySQL, the cloud environments are much bigger than that. And we might not know where our application is running, how many instances do we have. We can't really modify or like debug them because like locally you have the luxury, or maybe if you can have like access to that one box that your application is running on, you can have a luxury of looking into your application, getting better visibility. But you might not have this luxury in the cloud. You might not know where your application is or how many instances do you have. So with this size and complexity, after a certain size, it's guaranteed that something will be always broken in your system. And you might not know about this, you might will, but like troubleshooting these could be really hard in these systems. And it's I believe I found this analogy in a book that observability, or like not observability, but being in the cloud, it's like sending rovers to Mars. You cannot really modify them after lunch. They are like, you don't have access to them. They are just running. So you need to prepare them. You need to add like enough sensors and you need to capture the data that they are outputting so that you can observe them. Okay, does anyone know what are these images, or what can they refer to? Just place a comment if you know. If you don't, then I will explain them one by one. So the first image, it is called the Lorentz attractor. It is from math. It's from chaos theory, or you might know this as the butterfly effect. And I believe the Lorentz attractor was especially chosen for like representing this because it sort of looks like a butterfly. And what it says, like chaos theory, that a small change in the state of a system can result in a large difference in a later state of the same system. So basically you turn a knob here a little and services are going down in another region or somewhere else. And this is basically the reference to the insane complexity that we need to deal with nowadays. The second one, it is called the Dunning-Kruger effect. And it is a hypothetical cognitive bias that states that people tend to overestimate their own abilities. And if you look at this like competence, confidence graph, then it begins with low competence with high confidence. And being on that peak in the beginning, it feels like the same as being on the other end where you are basically an expert. And this might mean that we might think that we know a certain software system pretty well, but how can we make sure that we are not on that peak? And how can we make sure that we are not fooled by unknown unknowns? So this is a reference that we can't know anything because of the insane complexity that we need to deal with, and we need to deal with unknown unknowns no matter what. And the last one is, I'm not sure if it helped, or did we have any comments? Anyone tried to guess? No. So the third one, it is from a comic. It is an XKCD, it's a webcomic. And the title of this comic is Umwelt. And it's a German word. And this particular like episode of the comic, I'm not sure if it is available anymore, but what it did, when you visited the comic, it changed based on your browser, your resolution, your location, or the referrer tag. So the viewer, and what the viewer was viewing the comic on, where they lived or where they came from, determined like which comic they actually see. So if you check this comic on Internet Explorer, you saw a different one than you saw this through Firefox. And this is because Umwelt is the idea that because our senses like pick up different things, actually we live in very different worlds. Or basically the same thing can be perceived differently by different observers. Or they might physically see different things because they see them from a different perspective or angle or place or whatever. So I believe these three like very well defines like why do we need observability. So I would like to welcome you in the world of chaos, where we need to deal with insane complexity or maybe chaotic systems, unknown unknowns, and like everything is relative. And that's why we need to invest into observability. And there are a ton of like things that you can do here, but observability basically is the thing that will help you to ask questions that will help you to improve. And this can be from your application or CI/CD pipeline. How often are you deploying things? How often are you paged, and so on. So in order to improve something, you need to be able to measure it and observe it. And I have an interesting analogy for this one. As far as I know, especially in the US, business people usually like compared themselves to sharks, or people are comparing them to sharks. I'm not. I am the only one who heard about this analogy, or is it really a thing? I guess because of like Shark Tank, this should be a thing. So there are a few shark species in the world that need to move to get oxygen. If those sharks stop moving, they die. So I think this is very true for business and for software as well. If business or software, like they stop moving forward, they will not survive. And observability is one thing that helps you moving forward. Also, it will open you a lot of doors through like to chaos engineering, anomaly detections or detection using feature flags, A/B testing, auto-tuning your application, or like just having adaptive apps which are like adaptively tune themselves or react to the environment changes. So from this, let's move to the 3 pillars. I'm not a big fan of this name, but the so-called 3 pillars are basically like logging, metrics, and distributed tracing. And I have a very, very important thing here to note, that please notice that the definition we gave for observability, it did not contain any of these. It only said that how well can we understand or how well we can understand the internals of a system based on the output. It did not say observability is logging, metrics, and distributed tracing. But do they give meaningful information about what is going on inside of your system? Probably yes. So do they make your systems more observable? Yeah, probably. But logging, metrics, and distributed tracing, they are just one answer for the question of how can we make our systems more observable. There are other answers too. I am not going to talk about those today. And also there are like non-conventional components, which I will talk a little bit later. But we don't necessarily know if they are the right answer or not. But this is the most like widespread answer as of today. So let's look into them and let's talk about like what Spring can offer to support all of these. So logging, the first component, it is trying to answer the question for you, what happened? It is all about emitting like distinct events that are usually easy to manually read, for example, using grep. But please don't use grep to search for logs unless it's your local box. The next component, metrics, it should answer the question about like what is the context of this? What is the context of all of these events? What you can see happening, is it bad? Is it good? Is it all right? So it tries to measure and combine the data that you have. And it should be always aggregatable. And it's like a goal to identify trends, or one of the goals is identifying trends. The third component is distributed tracing. Distributed tracing tries to answer the question, like what is the cause of what you can see? Why that thing happened? And this is because distributed tracing is recording events with causal ordering. So it can identify cause across services. So that's why you will be able to answer the question, what was the cause of this? And let me give you an example through latency, and later like another example through errors. So if you have, for example, a latency issue or something is happening around the latency, you would just want to like observe it. Let's say that we found an event generated by an incoming HTTP request in the access logs, and that says this processing of this request took like 140 milliseconds. And after that, you can have the question like, okay, but what does it mean? Is it bad? What are the trends? Is 140 slow, or is it actually fast? What are the other requests? Are they around this, or is this like an outlier? And in the example in this distribution I put here, you can see that it was kind of slow. It's in the bottom like almost like 5%. So most of the requests were like faster than this. So now you know what happened, and also you can put it into perspective that this is not necessarily good. And distributed tracing should tell you like why this happened, or what was at least the cause. And this is not complete. This like, I don't know, diagram, but the idea is the same. I will tell you what is going on here. So distributed tracing tells you that sending the request to this service took like 5 milliseconds. And that is basically the network latency. Receiving from the response was like another 5 milliseconds. That's the network latency on the other way, because network is not necessarily homogeneous. And by the way, I saw this in the Wide, that sending a request took just a few milliseconds. Receiving it back, I have no idea what happened. Maybe it was routed elsewhere, or I don't know, but it took more time, which was like crazy. But you can basically point out issues like this with distributed tracing. And you also can see that like service A processing this request took like, let's say 130 milliseconds. And you can see the breakdown of this, that again, network latency 5 + 5, and service B was processing the request. It took like 100 milliseconds. And then you can see why service B was slow, and that goes on and on and on. So this is not, you can imagine, like you can basically break down the service B processing the request further. Maybe there is another service call, maybe there is a database, whatever. So it should work like this. It should tell you what was the cause. In the case of errors, basically, let's say we found a event generated by another like HTTP request in the logs, and that says 500 internal server error, which is not very descriptive, but we are also interested in what was the context. Like the is it bad question is interesting because like, yeah, it's failed. So most probably it's not good. But we might also want to know like what are the trends? How many errors do we have around this time? What was the error rate? What was the total errors in this like 10 minutes or 1 hour or something? And this is an example for that. This can tell you that at that time, you had like 2 errors per second. You can also see like how much errors did you have in total. And you can see that the others were just fine. So it's this was an outlier here there. And distributed tracing, it's very similar like than the latency case. You can see that where the error is coming from. And in some cases, you will be able to see that why as well. Okay, so these are basically the 3 pillars, and let's see what are those in practice and what Spring can give to you. So if you go back to the logging, there are multiple types of logs that you can have or you can utilize to make your systems more observable. And the most used is the standard application logs, like the classic debug info, error events, plus stack traces. But you can also have payload logs, which is basically a raw request and response pairs. Usually the secrets should be masked, or the sensitive part, but it can give you like a lot of details about what is going on under the hood. You can also have GC logs about the garbage collection events, access logs, which are logs from the underlying HTTP server that will answer you a ton of questions. I found them extremely useful. And the problem with logging in Java is this. This is basically the Java logging landscape. It's not simple at all. So what Spring does in order to solve this, and it is doing this like out of the box, it is using SLF4j with Logbook, and by default, then they come pre-configured. So SLF4j is basically a logging facade what it does, it provides you a simple API for various like logging frameworks, and you can basically plug these different logging frameworks in and out as you want. And one of these frameworks are Logbook, which is the modern logging framework, and it natively implements the SLF4j API, so it works out of the box. So if you are using Spring Boot, you will get this basically for free. It will be there out of the box. But you can also configure this, and if you don't want to use Logbook, but you want to use another framework, for example, Log4j, you just need to like switch a jar, and Spring Boot will do the trick for you. And in the previous slide, when I said pre-configured, I not just meant that the jars will be there so that you will be able to use the API. It is pre-configured in a manner that it will give you the Logbook XML configuration as well out of the box, which you can like override and configure yourself as well. Also for payload and access logs, these are projects that are not maintained by the Spring team, but there is a project called Logbook, and Logbook is for payload logging in Java. They also have like a Spring Boot starter, which auto-configure everything for you. And Logbook, it has a Logbook access module, and that is basically not auto-configured, but it's pretty easy to set it up. So with these, you can have like pretty good logging in your application. So let's move to metrics. As I said in the very beginning, micrometer, that is the default metrics library in Spring, and Spring is using this heavily. It's very popular. It's maybe the most popular metrics library in the JVM, and it is like SLF4j, but for metrics. It has a simple API. It provides abstraction over other like metrics backend. It comes with a Spring Boot actuator out of the box. And these Spring projects are instrumented using Micrometer, and also a lot of third-party libraries. They use Micrometer to instrument their code. So if you are using, I don't know, Hickory CP as your connection pool, Micrometer they have a Micrometer package for that, and it will work out of the box. And this is true for a lot of third-party libraries. And when I said it's like SLF4j, but for metrics, I thought something about this. These are the backends that Micrometer supports officially, and that you can use in order to ship metrics. And one of them is by VMware, called Wavefront, or I should say VMware Tanzu Observability by Wavefront, because I believe that's the official name of it. And I am going to show that later in this talk. Okay, let's talk about what Spring has to offer about distributed tracing. Spring's answer, or the distributed tracing support for Spring, it comes in a project called Spring Cloud Sleuth. And Spring Cloud Sleuth provides an abstraction layer on top of the tracing libraries. This is only true from the 3.x version, or from 3.0. Before that, it was only supporting Brave. So 2.x only supports Brave. In 3, this was abstracted out, and now it supports Brave, which is from the Open Zipkin community, and OpenTelemetry, which is a CNCF project. It basically provides you log correlation and context propagation for distributed tracing. It also provides support, like instrumentation support for the Spring portfolio, and also for your application. You can use the Sleuth APIs to instrument your code. Also, it has support for third-party libraries, but this support is not via Sleuth. It is through Brave and OpenTelemetry. And also it supports like various backends, and this is also through Brave and OpenTelemetry. Let's talk a little bit about OpenZipkin, because this is one of the like projects that you can use with Sleuth, and it's like very mature. It's production tested. Brave is the tracing library. Zipkin is the backend that will basically store your traces, and also a UI. It has multi-language support, and it supports many backends. OpenTelemetry, that's the other thing that you can use with Sleuth. It's a very new project. It's hosted by CNCF, and it was created from OpenTracing, or merging OpenTracing and OpenCensus together. But these projects are deprecated; they are not alive anymore. But OpenTelemetry is not just a distributed tracing solution. It wants to tackle like all the three pillars. It wants to solve the issues of logging, metrics, and tracing as well. It also has multi-language support. It supports multiple formats that you can use. And this is a very important slide about OpenTelemetry, because if you want to use OpenTelemetry, then you need to know that these tracing specs of OpenTelemetry, it is considered as stable. But the Java implementation of this specification is not stable yet. Also, the metrics and the logging parts, they are not. They don't have a released stable specification yet, and that's why Spring Cloud Sleuth Hotel, which is the project that integrates OpenTelemetry with Spring Cloud Sleuth, it is like an incubator project. The only milestone available, milestone releases are available, and right now it's not really recommended for production use. You can try it out though; it should work, and you should see your traces the same way as you would see them with using Brave. Also, we are collaborating with Total on tracing and on metrics as well. So hopefully, Spring Cloud Sleuth will have stable OpenTelemetry support soon. You might also want to visualize these traces, because without it, it's not very useful. So you can use a bunch of products for this. Zipkin is the go-to solution for Zipkin, because it's like a UI as well. Also, there is Jaeger and Haystack, and I believe there are more. There are APM vendors who are basically supporting distributed tracing, and also we have VMware Tanzu Observability by Wavefront. And this is a very long name, so in that slide, let me try to break it down for you. So VMware Tanzu, it's basically a Kubernetes platform across multiple clouds. And also it will give you features to implement DevSecOps. And in this multi-cloud environment, Wavefront is the observability solution that you can use to observe your applications or basically the whole system. And Wavefront supports the Zipkin format right now out of the box, and OTRP is on the roadmap as far as I know. And this leads us to this slide, which is about non-conventional observability, which is probably the most interesting for me here across these components. So the question after the three pillars or beyond the three pillars is there anything else beyond them? Is there anything else that can provide some outputs that will give you meaningful information about what is inside of your system? And if you can mention a few or like any, just put them into the comments. So our goal is basically having an output which provides meaningful information about what is inside of your system. I will wait like 5 seconds, and after that I will continue. Okay. So one of the things that you can do is you can put Spring Boot Actuator on your class path, which does exactly this. And I need to make two confessions here. The first one is Spring Boot Actuator is my favorite Spring project. And the second one is my favorite Actuator endpoints are health and info. And health is basically like it gives you like auto-configured health indicators, or it can also give you like health groups. For example, you can implement your Kubernetes liveness and readiness probes, but it has like other use cases as well. And if you have a application where you put Actuator in it, then you can see something like this. And depending on what you put on your class path, this can be like pretty big. For example, this one is so because I have a lot of features in this application, but essentially none of these were me. So I did not create a database health indicator. It was Spring itself. When it saw that, hey, there is a database, let me create a health check for you or a health indicator for you. And it was automatically registered to this instance so that you can see it. My other favorite info endpoint is maybe a little bit more interesting to me, but the interesting thing around this is that by default, it gives you a empty JSON. So one of my favorite endpoints does nothing by default, but what it does, it lets you and third-party components to fill it with content. So you can do very, very interesting things here in the info endpoint. For example, which environment are you running it? If you have ever deployed an application in production with the like wrong environment settings, for example, the staging settings in production, this can be a lifesaver. What build tools did you use? What build was used to, or what commit was used to build or create the build artifact on which branch, and when did that happen? When that build happened? What is the version of your application? What amount of memory do you have, or CPU? What are the available processors? These two are especially interesting if you are running in a Dockerized environment, because, for example, if in Kubernetes you don't set request and limits, for example, for your CPU, this one will be 1, which can have very serious consequences on your garbage collectors, because the serial GC will be chosen of course on your like parallel streams, because those will be sequential, and so on. Also, this tells you like the current Java version, which garbage collector is used. We are in the UTC time zone, in this country and language. This is my operating system version, some network details. This might not be very helpful in like if you are in Docker, and also like when the application was started and what is the current time of it. Most of this that you can see here, I implemented it, but it's like very, very easy. But these two, these comes almost like out of the box with Spring. If you are using Spring Boot, then you just need to like add one dependency maybe to your build, and you can turn them on. Okay. Other than these, you have a lot of other possibilities that you can. Oops, wait a second. Let me go back here. That you can use. It's basically endless. For example, you can put like cloud related information there. What's the instance ID, the instance type, the region, the account, which cloud provider is used for that particular service. If you are using, I don't know, HTTPS, and what is the certificate chain? What is the subject who issued that particular certificate? What is the expiration date of it? And so on. And also like Spring Boot Actuator gives you a ton of other features other than these two, like health and info. My other ones I really like is the beans endpoint. It basically tells you like what beans Spring created. The env endpoint, which is for settings. The 5A and the requeue base endpoint, which are like showing you the database migration info if you are using a database migration tool like them. And also I need to call out that though I really like this metrics endpoint, it is only for like debugging purposes. It's not a real metrics endpoint that you should use in production. Use a metrics backend with Micrometer. Also, you can create your own. Like you can put there, like you can have a endpoint like how to contact the dev team. Where is the repository of the project on GitHub? What dependencies do you use? Runtime? I don't know. Like the possibilities are basically endless. And also another component other than these, other than Spring Boot Actuator, is service registry. I find this is like very useful in terms of observability, and it can answer like very important questions, like how many services do you have, what versions are deployed, where they are, where you can find them, and when did they like started or stopped, or basically what is going on with them. There are a lot other non-conventional components. For example, API discoverability. I think this is important too. It will tell you like how or what APIs the service provide, and it can tell you like how can you call a service basically. There are a few projects around this. For example, Spring REST docs and the Swagger UI and the Hell Explorer. They will give you some UI where basically you can see the API documentation, or you can play with the API. Also, there is Spring Cloud Contract, which is for consumer-driven testing, and also there is Spring HateOS, which is a REST term. It stands for hypertext as the engine of the application state, and what it does, it basically puts like additional information, basically links between your REST resources. It increases API discoverability a lot. I really like it if it's on one of the APIs. Also, you can not just like observe your services, but you can also observe your CI/CD pipeline. So what's your build performance? How long does it take to create a build artifact? What's your build success rate? How frequently do you deploy? How long does it take the code to go to live? How many deployments fail? And so on. And there are others as well. If you have any idea, just let me know in the comments. But in the meantime, let me show you a little demo about this and how basically this could work for you with Spring. So let me share this. So this is Spring Initializer. And wait a second. Yes, I am sharing the whole desktop. So this is Spring Initializer, and I am going to create a small web application here. And I am going to use Gradle in case if Marcin is watching this. I'm going to use Java, the latest release of Spring Boot, or the latest stable release. And let me go like org. Let's build a robot service. And I am going to use like Java 11. Okay, so what I will need for this service, I am going to build a very simple web application. And I will try to observe this web application. So I will need Logbook. Let me use REST repositories just to, like, I don't want to write a controller now. Let's add JPA let's have H2 as a database, and I believe that's all I need for the application itself. Now I want to add logging, metrics, and distributed tracing support. So logging, it's the easiest. It's already there. Spring Boot comes with logging, the logging support I was talking about out of the box. If I want to add metrics, I need to add Spring Boot Actuator. And Spring Boot Actuator will bring in micrometer, so metrics should be covered. And as I said, for distributed tracing, I am going to use Spring Cloud Flute. So I have basically the support for logging, metrics, and distributed tracing, but I also want to ship this data somewhere. And that's where Wavefront comes into the play. So as far as I know, that's all I will need. I am going to use these projects to generate data, sending them to Wavefront, and let's see what does that look like. Okay, let me jump to the terminal, extract it, open it in IntelliJ. And the first thing I will do with this, before starting writing any code, I am going to add a other dependency. And I am only doing this because distributed tracing makes sense if you have a distributed system. And one application is not really distributed. I have only one app right now in this demo. I am not going to do multiple ones for now. But what I would like to do is see when the application calls the database, because at least I will have those two components. And in order to do that, I will add this P6Spy support for Brave, because by default, Sleuth is using Brave, and Brave has this P6Spy support, and P6Spy is basically the tracing instrumentation support for the databases. And also, in order to add P6Spy, I need to do this. I need to add a config file called spy.properties. And let me add a few lines there. This is basically telling P6Spy that it needs to use this tracing factory which is by Brave. And I want to see the parameter values in my selects, and I don't want P6Spy to basically do a hex encoding about the query. So with these settings, I should be able to see the text representation of it. Okay, so what else? Let me name this application, because that will be important if I want to know what is in Wavefront. I should see it what it is called. So let me call it robot service. And Wavefront also has an interesting term, which is the Spring application name is not the same as the Wavefront application name. The Wavefront application name is basically the name of your application group. If you have an application which consists of multiple services, then the name of the service will be unique per service, but you can group them together under one application. So, for example, if you would have multiple services here that I start, those will have different names, but in Wavefront, I can group them together under one. What else do I want? Maybe I want to, not this one. Let me expose the actuator endpoints. Please don't do this in production. or hide it somewhere. And in order to make P6Spy work with Spring Boot, I need to set up the driver class name. By default, you don't need to do this because by default, the H2 driver, because I'm using the H2 database, will be set up. But since I am instrumenting the H2 driver, I need to use this P6. Oops, why did this happen? P6Spy driver. Okay. And also I need to set the data source URL. Now the data source URL is like a very descriptive because it's like a JDBC database, JDBC. And on top of JDBC, there will be P6Spy. And it's an H2 database. It's an in-memory H2 database. And the name of the database, let's say, DB. And basically, that's all. What I need to do is just write the code. And in order to do that, I want to store a robot in the database. And since I'm using JPA, this should be an entity. And IntelliJ should scream at me right now. Come on, yes. I don't have an ID, and I need to add it for a primary key. So let me add it. I need to tell that this is an ID. And also, I don't really want to give this ID. I want this ID to be generated. And let me add just one more other field. Let's have a name for this robot. And in order to work, let me add the boilerplate with Logbook, like constructors, getters, setters, and so on. Okay. In order to be able to have like a web endpoint and also like a repository for the database, I need to add an interface. Let's call it robots repository, which should extend the paging and sorting repository. This is coming from Spring Data. And I need to tell that I want to store robots in this. And the ID or the primary key will be along. And this one thing that I did here, this will ensure that I will be able to persist robots into the database. And this, because of the Spring REST data support I added, it's right here. Because of this, I will have a CRUD's REST API on top of it. So basically, as far as I know, that's all I should do. And if I'm lucky, then this service should start. And I should be able to call it via a REST API. Now, there is another thing other than this REST endpoint creation that happened here. Because I added the Wavefront starter, if you don't have like a Wavefront API key, it will create you a freemium account, and it will place an API token onto your disk that you can use. So using this link, now I can jump to Wavefront for my freshly created freemium account, which is, in my case, it's not true because I had one in the disk. It was just restored, but it's still the freemium account. If I delete that file, it will register a new account for me. So let's hit this service. I have Postman here. I am like hitting the robots endpoint with a post request, and this will be the request I'm sending, or the request body. So let's create BB8. I don't know what other robots. TARS. Let's create a few ones. Marvin. What else? And let's do one more. Let's do Johnny 5. So I hopefully was able to create like all of these records. So if I hit the get endpoint, I should get those back. So I have BB8 here, Tors, Marvin, and so on. And as you can see here, this is the hate OS metric I talked about earlier. So I have the links between these resources. This endpoint robots, this will give me all of the robots, or actually it's not all of them because it's paginated. And it will give me like 20 of them if I would have that much. And it is also making me possible to jump to them directly by using their ID. And I can click it and just call it. So if I hit this a couple of times, and if I go back to IntelliJ, click on this link, which I have no idea why it is not opening, but let me open the browser. Then I am already logged in my account that the Wavefront starter created for me. Now I can see a lot of details about the services, or the one service I have right now. And what is going on here? These are metrics, or this is a dashboard created from the metrics shipped by Micrometer. So you can see the process uptime, you can see the CPU usage, the system load, the heap usage, the non-heap usage of the service, and another like a lot of things about your service or about your whole like infrastructure. This also have, as far as I know, Kubernetes support. So as far as I know, Kubernetes metrics can also show up here on another dashboard. So this also tells me that I have this application which is enabled for tracing. So I can browse those traces. So let's look at those. And here, let me sort it by time. So here, you can basically see all of the requests or all of the operations that the service made. And the whole thing is starting by basically creating the database itself. Then I was firing a couple of post requests, and these are the gets. So if I open one, I should see that this was a post request I made. And let me zoom in a little to this /robots endpoint. It was post. And what happened after is that was a database call, or actually two, which is interesting. Like, why was it two? And if you go into the text, you can see the SQL query. So the first request, or the first SQL query, was just to decide what will be the ID. And the second one is actually the insert query with that ID. And the same thing, if I go to the GET request, you can see that this was a GET to the robots endpoint with the ID of 1. And if I go to the select, I should see that this SQL query was executed. It's a little bit ugly because this is generated. It's Hibernate under the hood, but you can see that where robot.id is 1. So that matches with the ID that you can see here in the REST endpoint. And also there are a lot of things that you can explore here, and I encourage you to go to Spring.io, create a very simple application like this, and start playing with it with Wavefront, because there are a lot of small gems that you can see here. For example, if I am looking at the traces, I click on the, I clicked here, click on the name of the service, then I will see the metrics just for this single service. And basically that's all I wanted to show you on this demo. And that basically concludes my talk as well. If you have any questions, just let me know.
This is cool. And yeah, Sweet Color 9's an interesting idea theme.
Yeah, so the idea theme is, as far as I know, there is a plugin called Material UI, which will give you a lot of like dark and light themes. It's pretty good, and it is very well designed. I really like it.
Sounds like I need to take a look at that too. I installed it for the first time recently to do Java things for Spring One Tour. It was easier for me to just like mimic that instead of setting it up in VS Code when Josh was doing an idea.
Yeah.
Yeah, I like how like this is the first one we've had where someone had talked about like the experience of like interviewing or joining and all that. And I like how you like both were talking about that and then actually went into the observability things that you were kind of mentioning in the very beginning. So this is super cool and very different than what we've had before.
Cool, thank you.
Thank you as well. And I don't see any new questions. There's an awesome, but yeah. So thank you so much.
Yeah, thank you very much.
And
thanks for having me.
definitely, you should come on again. And also we need to play Among Us again. All right, well, thanks everyone for coming to Tanzu Tuesdays again, and to check out anything that we have, either Tanzu Tuesdays or other shows, just go to tanzu.tv. Thanks everyone.